Okay, so we all know AI is incredibly powerful, right? But that power comes with some pretty serious security risks. The good news, though, is that a new blueprint, a new architectural approach is starting to take shape. And honestly, it could completely change the game for how we build AI systems we can actually trust.
And it really boils down to this one huge question that every single security and IT leader is losing sleep over. How in the world do you let AI tap into your company's private data without, losing control of it completely? Right now, we're basically at a fork in the road. Down one path, you've got this wild, uncontrolled AI. You know the kind. It hallucinates facts, it leaks sensitive data, it's working off of stuff that's months or even years old. But the other path, that leads to what we're going to call grounded AI. This is the good stuff. Fact-based, secure, and running on real-time info. The choice feels like a no-brainer, right? But the real question is, how do we actually get there? All right, so the first piece of this whole puzzle is something called an embedding. The easiest way to think about it is like a digital fingerprint for your data. But here's the cool part. Instead of identifying a person, it identifies meaning. So what exactly is an embedding? At its core, it's just a long string of numbers, what mathematicians call a vector. But this vector is special. It captures the semantic meaning of a piece of data. It doesn't matter if it's text, an image, a log file, whatever. And the real magic is this. Concepts that are similar in meaning will have vectors that are super close to each other, mathematically speaking. That's the key to everything.
Okay, I know this might sound a little abstract or complicated, but stick with me. This isn't some brand new, out-of-the-blue idea. It's really just a powerful evolution of principles that you, especially if you're in cybersecurity, already know and use. Seriously, you're probably using this kind of thinking every single day.
And this really brings it home. Think about how we use malware signatures. Well, embeddings create what you could call semantic signatures to find similar threats, even when they're not a perfect match. Or what about fuzzy hashing, like SSDeep, that finds similar files? Embeddings do the exact same thing, but for meaning. It's even a lot like the baselines you see in UEBA systems, mapping normal user behavior to spot anything weird. Embeddings are basically the next-gen version of all of these ideas.
So this is where the security mindset has to kick in. If these embeddings are the fingerprints of meaning, then we have to ask the big, scary question. What happens if those fingerprints are wrong, or smudged, or worse? What if someone manipulates them on purpose?
And the risks here are, well, they're huge. Bad embeddings can lead straight to those AI hallucinations we're all worried about, where the model just starts making stuff up. They can let it blow right past your access controls, pull up completely irrelevant or even dangerous data, or connect sensitive info to the wrong question. And oh yeah, they are absolutely vulnerable to data poisoning attacks. So getting these embeddings right isn't just important, it's step one. It's non-negotiable.
Okay, so you've created these incredibly powerful digital fingerprints. Now what? You can't just leave them lying around. You need a safe place to keep them. And that brings us to the second key piece of our architecture, the vector database. Just think of it as the Fort Knox for all of the AI's knowledge. So a vector database isn't your regular old database. It's a highly specialized system built to do one thing and do it incredibly well. Store, index, and search through millions, sometimes billions of these embeddings. And the key is it searches based on that semantic similarity we talked about. It's not just matching keywords, it's matching meaning. Yeah, a really simple way to picture it is like a super secure, super intelligent filing cabinet for all those digital fingerprints. A normal filing cabinet is organized alphabetically, right? This one is organized by meaning. It doesn't just know what's in the file, it knows what the file is truly about. And here we go again. Look how neatly this maps to security concepts we already live and breathe. A SIM, a security information and event management system, indexes logs so you can search them fast, right? Well, a vector database does the same thing, but for semantic knowledge. It's got to be an access-controlled repository, enforcing authentication, just like a file server. And you can even think of it like a DLP, a data loss prevention system, because it can tag and protect the vectors that come from your most sensitive info. So it probably goes without saying, but if your secure vault isn't actually, secure, you're in for a world of pain. Insecure vector storage leads directly to some pretty nasty outcomes. For starters, private data can leak out during the retrieval process. Even scarier, a determined attacker might be able to reverse engineer the original sensitive text from the vectors. The whole index could be poisoned with bad data, tricking the AI into making awful decisions based on those hallucinations. It's a nightmare scenario.
But when you get this right, the story flips completely. A properly secured vector database becomes the bedrock, the foundation, that ensures all of these protections. It makes sure that AI plays by the rules, respecting the access controls you already have. It means your sensitive documents stay protected, period. Every single query becomes auditable and reproducible, so you can always see the receipt for how the AI got its answer. It really is the only way to build a reliable and safe foundation for AI.
Okay, so we've got our secure fingerprints, the embeddings, and we've got our secure vault, the vector database. Now it's time to put it all together into the actual security architecture. And this whole system has a name. It's called Retrieval Augmented Generation. You'll hear people call it RAG for short.
Let's just walk through how this actually works, because it's pretty elegant. Step 1, a user asks a question. Simple enough. Step 2, the system turns that question into its own embedding. Then, and this is the cool part, the vector database does a lightning-fast search to find the most relevant documents based on that meaning. Now, here is the absolute most critical part. That factual retrieved data gets packaged up and sent to the LLM with the original question. It's only then that the LLM generates an answer. See the difference? It's not guessing from its vast, fuzzy memory. It's synthesizing an answer based on hard facts you just gave it. And that right there is why RAG is such a security game changer. For one, it slashes those dangerous hallucinations way, way down. It also keeps your sensitive data right where it belongs, in your secure database, not getting baked into some mysterious third-party model. It means the AI is always using the latest, up-to-date information. And maybe most importantly of all, it means you keep ownership and control of your data. Full stop.
So when you zoom out and look at the whole picture, it becomes pretty clear that this isn't just some clever little trick. What we're actually witnessing here is the new standard for how to build responsible and truly trustworthy AI inside an enterprise.
I mean, this table just lays it all out perfectly. You're worried about hallucinations and guessing? RAG grounds the answers in your own verified data. Solved. Worried about data leakage? RAG keeps that sensitive info out of the model's brain. Solved. Worried about outdated knowledge? RAG pulls real-time info on demand. Solved. For every major security headache with AI, the RAG framework offers a clear architectural solution. It's that powerful. And believe it or not, the benefits go even beyond security. Think about it. By grounding the AI in well-curated data, you can actively reduce bias. You can design the retrieval process to enforce specific fairness policies. And the whole outdated knowledge problem, it just disappears. The AI's knowledge is updated instantly the second you add a new document. That's a huge deal for keeping the system robust and relevant. So if there is one thing you take away from all of this, let it be this. RAG, Retrieval Augmented Generation, is quickly becoming the standard architecture. It's the blueprint for any company that's serious about building AI that is secure, reliable, and ready for the enterprise. And that leaves us with one last big question to chew on. If we finally have a reliable blueprint to ground AI in facts we can actually verify and audit, what does that make possible? What's the next frontier? What's the next big hurdle we have to clear to build real, lasting trust between us and these incredibly powerful technologies?